According to the curriculum, you have to know how to write basic formulae, and you need to be able to balance chemical equations. So the first thing we're going to do is just remind ourselves of how we do the formulae. I'm just going to read through the polyatomic ions that you are expected to know. They're all on the sheet. Unfortunately, you do have to learn them at this stage. So it's the ammonium ion, the chlorate ion, the ethanoate ion. That now we've done organic chemistry, it's CH3, COO. The hydroxide ion, which is OH minus, nitrate, nitrite, permanganate, hydrogen carbonate, hydrogen sulfate, carbonate, dichromate, sulfate, sulfite, and phosphate. So with that in mind, let's do the carbonate bit over here. And we have to go, it's zinc. Zinc does not require a stock notation, so we're just going to go zinc carbonate. If I had something like this, we need to also know a little bit about the periodic table, and remember that Fe is iron, and it is iron chloride, because it's just the chlorine over there. And then we must remember that iron is in the transition elements, so we are going to have to work out what the stock notation is. The formula tells me I've got 1 iron and 3 chlorines. Each of those chlorines have got a valency of 1 because it's in group 7. And then what I'm going to do is I'm going to check over there how many arms must that iron have. 1, 2, 3. So it becomes iron 3 chloride. When we want to balance equations, remember, we check how many. Remember, these are known as the reactants. These are the products. Left-hand side reactants, right-hand side products. Remember that we have to conserve mass in a balanced equation. That means the same number of atoms have to be on the left as they are on the right, or the same mass of particles on the left as on the right. So in other words, if I got the molar mass and worked out the mass of zinc plus the mass of hydrochloric acid, it would turn out to be the same as the mass of zinc chloride plus the mass of hydrogen. How do I do that? 1 zinc on the left, a zinc on the right. Yay! 1 hydrogen on the left, 2 hydrogens on the right, 1 chlorine on the left, 2 chlorines on the right. So I can just pop a balancing 2 in there and everything is balanced. Remember, you also do need to know a couple of definitions. A mole, what is a mole? It is the SI unit for the amount of substance. And it has 6,02 times 10 to the 23 particles in it. Defining molar mass is a mass in grams of 1 mole of any substance. The definition for molar volume is not required, but I can certainly ask you to explain what molar volume is. So, what is molar volume? It is the volume of 1 mole of gas at standard temperature and pressure. Now, standard temperature and pressure is going to be 273 Kelvin and 273 Kelvin and 1 atmosphere of pressure, which is 101.3 kilopascals. They're not probably going to ask you that in great detail this year. It comes up quite a lot next year, but you just need to be aware that 1 mole of any gas at STP, you do need to know that it's STP, is 22,4 decimeters cubed. Right, and we've got a very simple link. Actually, number of moles is equal to mass over molar mass. These are given on the information sheet, which is the same as number of particles over Avogadro's number, which is the same as volume over molar volume. Let's try and apply that to an example. Let's use the equation that we just used earlier. So zinc and hydrochloric acid gives me zinc chloride plus hydrogen. Let's say I was given 98 grams of zinc and 73 grams of hydrogen chloride. And the question asked me, or hydrochloric acid, whichever, how many moles of reactants do I have here? So if I want number of moles and I've been given mass, I'm going to go number of moles is equal to mass over molar mass. I've been given 98. I divide that by the molar mass of zinc, which is 65,4, and I land up with approximately 1,5 moles. That's of the zinc. And then the number of moles of the hydrogen chloride is 73. I divide that by 36,5, and I find that I get 2 moles of zinc. So that's what I've been given. Then says how many, sorry, not of zinc, of hydrogen chloride. So I then say so now we know we've got 1,5 moles of that, and we've got 2 moles of hydrochloric acid. What we now need to do is we now need to take a look what they ask us a question. Oh, first let's say how many atoms of zinc do I have? So I've got 1,5 moles of zinc. Let's try and work out the number of atoms there. So I'm going to say number of particles is equal to number of moles times Avogadro's number, which is equal to 1,5 times 6,02 times 10 to the power of 23, and I land up with an answer of around about 9 times 10 to the power of 23 atoms of zinc. So that's done. Now they want us to know what is the limiting reagent. I need these to react in a ratio of 1:2. I've got 1,5 there and I've got 2 there. So obviously I need to say I need 1 here, I need 2 there, which means that this is where I come unstuck. I can't make another, I'm going to have 0,5 of the zinc over. So what's my limiting reagent? The HCl is my limiting reagent. What mass of zinc chloride am I going to make? Now I have to use my limiting reagent if I'm going to do a calculation regarding the zinc chloride. So let's try and take a look at that. I'm going to say I have got 2 moles of HCl, and I want to see how much zinc chloride I make, and that's going to be a 2:1 ratio. But in this story, I do have 2 moles, so I'm only going to make 1 mole of zinc chloride. So I take that 1 mole and I say mass is equal to number of moles times molar mass. I'm only going to make 1 mole of zinc chloride. The molar mass of zinc chloride, when I add 1 zinc and 2 35,5s together, I land up with 136,4, and therefore I get 136,4 grams of zinc chloride being made. What volume of hydrogen am I going to make? Again, I have to use my limiting reagent. So I'm going to say this time that I have got HCl in a relationship with hydrogen. I need 2 HCl's to make 1 hydrogen according to this balanced equation over here. And therefore, I am going to make 1 mole of hydrogen gas. The question is volume. Volume is going to be equal to number of moles times molar volume. I use this equation here, volume, number of moles times molar volume. If you need to draw a triangle, let's just draw one quickly. Volume's at the top, number of moles and molar volume are at the bottom. I'm going to go 1 times 22,4, and I land up with 22,4 decimeters cubed being made. Be aware of the fact that 22,4 is going to be on the information sheet, so you don't have to commission that to memory. And the last question they ask me is, what is the percentage yield of zinc chloride if I make 190 grams? Well, I know that that can't be 190. Let's make it 100 grams. Okay, so if I'm going to make 100 grams, so I did make 136,4. So percentage yield is equal to how much did I make out of how much should I have made, and this was the maximum that could have been made, times by 100, and I'm going to get an answer of 73%. So they can ask a question like this that could easily then include all of the different rules you've learned about quantitative chemistry, all of your formulas, all of the manipulation around stoichiometry and balancing equations and using mole ratios and all of those sort of things. Remember that concentration and solutions is also part of the equation. Remember that you are expected to know the definition, that a standard solution is a solution of known concentration. And you need to know that you've got a solute, which is the substance that is dissolved in the solution. You need to know that you've got a solvent, which is the substance in which something is being dissolved. And a solution is solvent and solute mixed in a certain ratio. And you then have to work out concentration, which is concentration is equal to number of moles divided by volume. And we need to be able to calculate that. So the first one, hydrochloric acid is made by dissolving 0.5 moles of hydrogen chloride into 2 decimeters cubed. What is that mass of hydrogen chloride? Well, mass is equal to number of moles times molar mass. So it's 0.5 moles, they told me that. The molar mass of HCl is 35.5 plus 1 from the hydrogen, and I land up with 18.25 grams. Then they ask what is the concentration. Concentration is a number of moles, 0.5, given, divided by volume. In decimeters cubed already given, lovely. So I land up with 0.25 moles per cubic decimeter. That's pretty simple stuff. That's all level 2 things. Now we go on to a level 3-ish question. How much water must be added in order to reduce this concentration over here? Let's, this question's not 100% complete. Must be added to, let's say, 200 milliliters in order to make that concentration. Watch what we're going to do. First, we're going to say we have got 200 milliliters, and 200 milliliters, if you remember, is 200 centimeters cubed. Remember your conversions, which is 0.2 decimeters cubed. So that's our solution, and that solution we already know has a concentration of 0.25 moles per cubic decimeter. We then know that what we want is we would like a solution with 0.1 mole per cubic decimeter. So we take all of these moles, number of moles is equal to concentration times volume, 0.2 times by 0.25, and we get 0.05 moles. So 0.05 moles goes into the new container. Let's work out what volume we require in the new container. Volume is equal to number of moles divided by concentration. The triangle looks like this. Number of moles at the top, volume and concentration at the bottom. I've got a number of moles, 0.05, divided by a concentration of 0.1. And I find that I need to get to 500, rather it was 0.5 decimeters cubed. I already had 0.2 decimeters cubed. So how much water must I add to get to 0.5? I must add 0.3 decimeters cubed of water.